one of the problems with general off-chain data with things like emails is that it's hard to bring on-chain verifiably. Most protocols that do attestations, even ZK attestations, rely on some central protocol itself signing an attestation to that data. Ultimately, this can be an MPC, an oracle, or an enclave, but it still fundamentally undercuts the premise that the entire thing is happening in a decentralized way. So today, Sora and I will be chatting about ZK email and how it can be used to do not identity attestations, but provenant identity. And we're excited to discuss the way that this technology works, and a huge shout out to the folks that have contributed to the technology so far. Salil, Rasul, Wacharu, Alo's in the front, Tyler, and a number of folks who jumped in the last second to make sure that everything worked end to end. So what exactly is ZK email and how does it solve these problems? The idea is that these proofs of email can allow for programmably provenant data. This means that the verified data, instead of being from a signature of a centralized attester, is from the original mail server. So for instance, if Twitter wants to verify some username, you're verifying a signature from Twitter directly. This gives provenance to all of the data that we look at. Second, we can prove and extract arbitrary information in this email via ZK regex. This makes the entire proof programmable, meaning you can choose what you want to program and how you want to extract and what you want to make public and private. But how does this work? It turns out that every email you've sent or received since 2017 is signed with an RSA signature. The DKIM protocol specifies that in order to pass the spam filters, you need an RSA signature from the sending mail server of the SHA hash, of the from, the to, the subject, and the hash of the email body. This is signed with the RSA private key of the domain, for which the public key is posted on DNS. As a result, we can verify this entire process within a ZK proof, verify the RSA signature, the SHA hashing, and throw a regex on top of it within the ZK proof so that we only reveal specific data. So the way this would work is that when a user sends or receives an email, the sender email domain service attaches a signature to that email, which the user then extracts into the ZK proof. The ZK proof can prove something, for instance, just the from address in this case, and then prove that proof on Ethereum. So how exactly would this flow work for instance, Twitter? You can see at the bottom of this email, I have my username circled in the very bottom. In order to extract that, we would have to verify the headers, that is the from, the to, the RSA signature, which you can get from the top of the email. Subsequently, we hash the bottom of the email, we run the regex on this section in order to find this string, and we extract out the username. This primitive is really powerful because it's not just Twitter emails you can extract from. We've seen a number of people launch really interesting applications. For instance, ZK P2P launched a peer-to-peer on-ramping and off-ramping service via Venmo. By proving the contents of a Venmo email and the amount in that transaction, you can now directly transfer a Venmo transaction to a USDC on-chain. It's actually not on testnet anymore. If you go to the demo, you can try their mainnet demo. In addition, there's a number of other proof of identity applications you can build, such as proof of Twitter, proof of GitHub by proving confirmation from GitHub emails, proof of organization by, for instance, proving you work at a certain email domain, or proof of KYC by proving that you received an email from a KYC provider like Coinbase or Airbnb and reusing that email anywhere else. The specific application, though, that we'll be talking about today is email wallet.
So we can use ZK email not only for building a new kinds of application, but also for reducing the cost to start using Ethereum. So our question here is, how can we send tokens to our payloads? Our answer is just send an email. So our email wallet, contract wallet using ZK email, helps the onboarding of non-clipped users with those three features. First, user can make an Ethereum transaction simply by sending an email. And next, user can call not only for token transfer, user can call any smart contract by changing the email subject. And third, our organization or even smart contract can send digital assets to people use the recipient's email address. So it does not require recipient's Ethereum address. So let's show you an example. So if you want to send ERC20 tokens by sending emails, you can write subject, You can send the subject like this way. Send 1.23 ETH to bob@gmail.com. And then you send this email to the layer, which is the non-custodial server to help email wallets. And then assets in your wallet is sent to the wallet for the recipient's email address. And we can extend this functionality by extensions. So for example, if you write subject like swap 1.3 ETH to DAI, then ETH in your wallet is automatically exchanged with DAI via Uniswap. And we can also send NFT like this subject. So in this way, we can extend our functionality of email wallet by building a new kinds of extensions and defining the subject template for each extension.
Sweet. So we have a demo up right now that people can try if you go to emailwallet.org. You can scan the QR code, and we'll walk people through how this flow should look. The QR code will continue to be on the screen as we show the flow. So if you go to this website and you hit Try Demo and you go to the application, you can then go to the Create Account screen. In this screen, you simply input your email address and you hit Create Account. What this is doing behind the scenes is generating a local private code that will shield this email address on-chain so that this is not publicly revealed. Subsequently, when you hit Create, it will draft this email. We have a relayer deployed at arbitrum@senddeep.org, which is actually going to send this transaction on mainnet in order to create a wallet address for you. This code will be shared with the relayer temporarily so that they can create an address for you and ensure that your specific email address will not be revealed on-chain. We attach some additional email information to the email so that you know what is going on, but the actual thing that is parsed on-chain is only this subject field. Once you send that email, you'll get a response that looks something like this. It will say that it's deployed a wallet for you at this address, and you can see it on the Arbitrum mainnet. And you can also see the transaction, which proved your email in order to deploy this wallet. Subsequently, you can send test tokens if you'd like, and for the duration of Devconnect, we're giving all people who sign up 5 USDC, up to a limit. Because it's on Arbitrum mainnet, we recommend that people don't send a ton of money right now. We've limited accounts to send and receive $100 worth of money in order to ensure that this experiment makes sense. And so we intend for the smart contracts to wind down after 2 weeks so that we can have a contained experience in which folks can try it out and see how it works. Once you've created your account, you can now send money. So you'll go to the send money screen in which you can input the person you want to send to and the subject, which specifies the amount of money you want to send. In this case, we'll be sending 5 USDC to the Nessim Math Village. We're excited about this because the Math Village helps provide education near Istanbul, and so we think that by sending 5 USDC to them, we can help support them. And so subsequently, when you hit that button, it will go to this email and fill in the subject, sending 5 USDC. We have some additional details again in the body, but these aren't actually parsed on-chain. Once you send that, you'll again get a confirmation that the 5 USDC has sent to that recipient. Again, our wallet address is linked, and you can see the Etherscan link. And if that recipient email address wants to claim this transaction, they can simply create their own email wallet and claim it. It's really interesting that the recipient never has to have interacted with this protocol before in order to claim the money.
So do you enjoy our demo? Thank you. Okay, so I'll next explain the more detail of how Jig email wallet works. So in your first email, you see some invitation code like 0x and hex string. So actually, this is the account key for your wallet, and this account key is used only to derive your wallet address. But this is not the kind of spending key to spend your parts in your wallet. And when you send the email to send tokens to someone, then the layer receives this email and generates proof of your email and submit this word to our contracts. And then your wallet contract will send token to our core contract, email wallet core contract. And this core contract also verifies proofs. And at that time, this fund is kept in the core contract because maybe this recipient does not have any account in this when the sender sends tokens to the recipient's email address. So after recipients creates their email wallet account, then its recipient's layer can claim their funds from core contract to recipient's account contract, like this way. And we have more kind of security and privacy features. So first, our layer server is already decentralized. So it means even if your current layer censorships your transactions, you can start using different layers just by sharing your email with the account key to different layers. And you can, since this is an open source implementation, you can also self-host this layer. And these layers communicate with each other by using private set intersection to keep the private data of the email address of the users. And also, even if you send your token to your email address, which is used by nobody, then you can reclaim, the sender can reclaim this transport token from the core contract to the sender's wallet after 30 days.
We have a number of other features. For instance, one of the tricky parts of this protocol is getting that public key on chain. And so because these keys rotate every 6 months or so, we want to ensure that we can adequately rotate the key without allowing anyone to censor transactions. So for instance, if that email server leaks that private key as is specified as a recommendation, but most email servers don't do this, then in order to ensure that funds cannot be stolen, if that private key is ever sent publicly on chain, it will immediately invalidate the key, and that is the only way to invalidate keys or censor transactions. By default, we have a DFINITY-based DKIM registry that is just querying the DNS and relaying it on chain. But if you don't trust that, you can self-host your DKIM key as well, and so there's no trust assumption on the DKIM key mirroring. Finally, the privacy on chain is not just that the email addresses are unlinked to your wallet address on chain. We also provide UTXO forward compatibility. This means that if someone in the future wanted to, say, put up a UTXO-based wallet to do these transactions, they can, and they can use the existing framework for email wallets to seamlessly migrate to that. In addition, we have a really powerful extensions framework that allows anyone to build whatever they want on top of ZK email and email wallet without knowing any knowledge of ZK. So for instance, by specifying just 20 lines of solidity, you can parse a new type of subject. For instance, swapping some amount of token to some other token. This can be defined just with string parsing and subsequently calling the relevant contract on chain. This means that you can specify how you want to interact with this email wallet in natural language. It also means that you can onboard many people at once. Instead of just sending one email, you can define an extension that allows you to onboard, say, 100 people at once. You can also secretly make ticketing emails, for instance, emails that are sending you NFTs. So maybe when you got a ticket to the Taylor Swift concert, you had no idea, but behind in the back end, it was actually also sending that email wallet an NFT of that ticket, but the user has no idea. And so we're really excited for how existing emails can easily be ported to an email wallet email by just creating a small Solidity contract that will parse that email. And this, we think, is a really powerful primitive. You don't have to buy into the specific standards that we've created. In this ecosystem, you only have to create an extension, and that allows you to convert any existing email. Finally, if you want the flow to be even easier, instead of sending a transaction per email, but a single transaction to authenticate, you can also write an extension that just allows you to delegate an ephemeral key and subsequently authorize all future transactions from, say, inside a browser tab, making this flow very similar to something like Magic Link. If you want to build your own ZK email proofs, for instance, the system that we use to build email wallet and all the other proofs of email, you can use our open source and audited SDKs. We have, for instance, a set of Circom libraries that allows you to construct both novel regex proofs and front-end smart contract code and ZK proofs for new types of emails. In case you want to do this client-side, we also have Halo 2 code that makes client-side proving really quick. This is still audit in progress, but we expect that to be finished sometime near the beginning of next year. We have a decent amount of tooling. Because of our SDKs are public, we had, for instance, a developer build a way to parse the regex automatically and construct a circom circuit in a front end, making this even easier to put up your first circuit. The SDKs are really powerful. We saw in one weekend someone put up a two-factor authentication on your wallet transactions via Knows is Safe. The way this works is that, for instance, if you ever have a transaction more than $1,000 from your normal wallet, it asks you for 2FA from your Knows is Safe via your email in order to authenticate that transaction. We're really excited by applications like this, and by making all of our code open source and publicly accessible, we think people can build a lot of really cool applications. We have a ton of ideas on our GitHub repo. If you go to prove.email, you can see a number of these. There's so many emails in your inbox that provide a really rich source of provenant data information that people can then attest to create all sorts of interesting applications. We have a couple here, for instance, flights from your airplane confirmation, residence from your tax reports, credit score from, say, an Equifax confirmation, bounty whistleblowing. You can say that, for instance, I will put a bounty of, say, $10 on an email that contains, say, a domain that's at ftx.com and mentions a specific person in it. And you can incentivize people working there to then publish those emails on chain. In addition, you can donate to research. You can donate to GitHub repos as long as email addresses are linked to people's GitHub commits. And overall, it's a really powerful framework. We have a number of additional ideas for infrastructure and general ideation as well on our GitHub repo, which you can see if you go to this link. If you want to talk more, we have a Telegram. We're happy to answer any questions, and all of the links from this presentation, including the slides, will be mentioned in the Telegram. If you want to talk more, we'll have a booth. The proof of email booth. We'll be doing tutorials, workshops, and office hours to help people put up their first proofs of email and email wallet extensions. We also have some special puzzles for people who really like optimizing stuff, and we'll have prizes and swag for that as well. So we're really excited to see what people do, and thank you for coming.
Thank you.
You can also see that the transactions that were happening during our presentation are relayed on Etherscan, and you can see that each specific transaction, for instance, is sending the 5 USDC as soon as someone sends an email.
Since you guys were speedy, if you want to take a couple of minutes, we could take a couple questions if anyone has any.
Yeah, if anyone has questions, feel free to raise your hand or come up to the mics in front, and we're happy to answer anything. Well, maybe wait a couple minutes. Yeah, do you want to come to the mic in front and then ask, or take the mic from up here?
So with these extensions, you said the first one where you can do custom stuff, doesn't it also require to recreate the circuits, or are the circuits so flexible with the regex stuff?
Yeah, it's a great question. So the way the circuits work is you can specify the specific private and public information you want revealed on chain. So for instance, in this case, we would pass the entire plain text of, say, swap token amount 2 on chain. And depending on if you wanted that string to be public or private, you can specify whether it's public or private. And so the language allows you to use the exact same circuit verifier and change the way the strings are parsed directly on chain.
So for the client version, our circuit reveals all of the subject except for the email address in the subject. So if you like, so for example, if you write a template like recipients in this subject template, this subject is kept private, and only its commitment data is revealed on chain.
That explains it. Thank you.
Thank you.
Back here?
Back. Thank you. So, a question. I guess the secrets rely also on the keys of the mail providers. So, how you deal with the rotation of keys or deprecation of keys?
Yeah, so the way this works right now is, by default, how do we handle these key rotations? And so the private key leaking is only if the mail servers opted to release their key, in which most mail servers actually don't do. They just rotate their key. And so the idea is that before you hit the contract, this like definity network will ensure that the key that you're actually using is the most recent key. And if it's not, then it'll update the one on chain to the most recent version. And so you know that every time you send an email, it'll actually be using the most recent version of the key in DNS. And so, yeah, the way this rotation works is if you want to self-host it, is that every time the key changes, then you can just send a transaction to your own contract and then update that yourself. And so that's how we handle the rotations. Sweet. Thanks for the question. Or
All right, last one.
Thank you. Very exciting project. Saw that you mentioned CK email is, well, the Circum version is audited and the Halo 2 one is audit in progress. Curious, does that audit covers just the CK email code base, or does it also include like the Circum tech stack or the Halo 2 tech stack as well?
yeah, so it's a great question. Like, what exactly has been audited here? So we've audited the end-to-end circuits for Circom. This is usually easier for server-side based proving because often these take slightly longer to do in the browser. But we've audited the RSA, the SHA, the regex, the compiler, and end-to-end flow, and we intend to have more audits next year. For Halo 2, we're waiting on the SDKs we use from Axiom to finish being audited, at which point our SDKs will begin being audited, and so we expect that to happen sometime in 2024. But yes, this will audit the entire end-to-end flow down from the Halo 2 primitives all the way up to the regex compiler that people build to create custom circuits. Sweet. Thank you for the questions, and thank you for coming. We'll be around to continue to answer questions.